My dear students, in a previous video, we solved some problems in the exercise 3.4. That is, find the inverse of the given matrix. That is the problem we have solved already in our previous video. The matrices we solved in the previous video are 2 by 2 matrices. We have determined the inverses of 2 by 2 matrices by using the elementary operations we have seen in the previous video. Now in this video, I am going to continue the exercise 3.4, but using the elementary operations, we are going to find the inverse of the 3 by 3 matrix. It's somewhat some bigger problem. Using the elementary operations, we have to find out the inverse of a 3 by 3 matrix. That is our task now. The problem number 15 in the exercise 3.4 is this. Find the inverse of the matrix 2 minus 3, 3, 2, 2, 3, 3 minus 2, 2. A 3 by 3 matrix. I will consider the given matrix by A. We know by matrix equation A is equal to IA. I is the identity matrix of order 3. Therefore, it is telling that A is what? 2 minus 3, 3, 2, 2, 3, and 3 minus 2, 2, this is A, equal to, what is I? I is identity of order 3, 1, 0, 0, 0, 1, 0, 0, 0, 1. This is identity of our matrix of order 3 into A. A equal to IA. This is the matrix equation. Now we are going to apply elementary operations on both sides of this equation, and we convert the left-hand side matrix into a unit matrix of order 3, and automatically the right-hand side matrix becomes the inverse of A. That is, we know that I equal to A inverse into A. We are converting this equation. A equal to A is converted into I equal to A inverse into A. We are converting this A matrix into identity matrix. This automatically the identity matrix becomes inverse of A using elementary operations. I already told you elementary operations are two types. One are using row operations or column operations. Column operations means, just recall you, this is column 1. By adding column 1 plus column 2, elements of adding column 1 and column 2 gives you column 1. That means this is column 1 and this is column 2. This is C2, this is C1 you see. C1 plus C2 means horizontal addition. Like that. C1 plus C2. You write it by C1. C1 plus C2. Just adding the columns, that is called vertical addition. Columns C1, C2, adding the elements, element wise you add. Row operation is nothing but R1 is R2 minus R1. For example, you say this is R1, this is R2, R2 minus R1, like this is horizontal operation, this is vertical operation. Column is vertical. Vertically you add element wise the two columns. Row operation is horizontal addition of row or subtraction. This is elements of R2 is subtracted from R1, that is R2 minus R1, R2 minus R1, R2 minus R1, and write it the elements in the R1. R2 minus R1 and you write in this row, first row. Like that the operations are operated, you mind it. Using this idea, I am going to find the inverse of the given matrix A, the 15th problem. So, as I told you, first row, first column element, we have to convert 1 immediately. For that, I interchange row 1 to row 3 and row 3 to row 1. R1 element to R3 and R3 element to R1. I interchanging the R1 R3. That is, third row becomes first row. That is 3 minus 2, 2, 2, 2, 3 and 2 minus 3, 3. This is the first operation. R1 becomes R3, R3 becomes R2. Similarly, on the right hand side, R3 becomes R1 and R2 as it is, right? And R1 becomes in the place of R3, 1, 0, 0. This is our first operation in ETA. It's a lengthy one. The board is very small, therefore I am erasing the previous step. And I am continuing the problem. See, this is the first operation. After that, you subtract R1 elements from R2 and write it in R1. That is, R1 is R1 minus R2. That is the first operation. Next one is, first we interchange R1 elements into R3 and R3 into R1. Next, R1 elements are subtracted from R2. That is, next stage is R1 is R1 minus R3. R1 is R1 minus R3. R1 elements are subtracting from R2. 3 minus 2, 1. I already told you, like that you have to subtract R1 minus R2. This is R1, this is R2. R1 minus R2, 3 minus 2, 1. Minus 2, minus of minus 3 plus 3. So R1, 3 minus 2, 1. R1 minus R3, this is minus of minus plus 3. So plus 3 minus 2, 1. And 2 minus 3, minus 1. The rest of those are as you should write 2, 2, 3, and 2 minus 3, 3. The same operation you would have operated on right hand side also. R2, R1 minus R3, 3 minus 2, 1, 2 plus 3, 1, 2 minus 3 minus 1. Similarly, 0 minus 1, minus 1, R1 minus R3, 0 minus 0, 0, 1 minus 0, 1. So the remaining elements are as usual, 0, 1, 0, 0, 1, 0, 1, 0, 0. This is the next. Our next idea is R1. Okay. R2 minus R3. Next, R2 elements are, you have to convert 2 minus 2, 0, it becomes 0. Therefore, R2 is R2 minus R3. For that, 1, 1 minus 1. R2 minus R3, 2 minus 2, 0. 2 minus of minus 3 plus 3, 2 plus 3, 5. And 3 minus 3, 0. Okay. And third row as it is 2 minus 3. This is equal to minus 1, 0, 1. R2 minus R3. R2 minus R3. 0 minus 1, minus 1. 1 minus 0, 1. 0 minus 0, 0. And 1, 0, 0 as it is. In TA. In TA you have. Next. Another operation, you now convert this 2 into 0 for that. R3 is R3 minus 2R1. Our next operation is R3 minus 2R1. Next, R3 is R3 minus 2 times of R1. Then only it becomes 0. 2. If 2 into 1 is 2, 2 minus 2, 0. For that, see, 1, 1 minus 1 as it is, right? R2 is also 0, 5, 0. Next, R3 minus 2R1. 2 times of R1 is 2. 2 minus 2, 0. 3 minus 3 into 2. 2 into 1 is 2. Minus 2. 3 minus of minus 2. 3 minus 2 minus 3 minus 5. because minus 3, 2 times of minus 2 into 1 is minus 2, minus 3 minus 2 minus 5, and 3 into minus 2 is minus 1 into minus 2 plus 2, 3 plus 2, 5. Good. And here also minus 1, 0, 1, minus 1, 1, 0, R3 minus 2 R1, R3 1, minus 2 into 1 is plus 2, 1, minus into minus plus 2, 1 plus 2, 3, R3 minus 2 R1, 0, both are 0, 0, R3 minus 2 R1 minus 2. Okay. Next, you divide R2 elements by 5 and R3 elements also divided by 5 because 5 are common in both R1, R2 and R3. For that, I get 1, 1 minus 1 as it is. R2 divided by 5. Each element is of R2 divided by 5. 0 by 0, 5 by 5, 1, 0 by 5, 0. 0 by 5, 0, minus 5 by 5, minus 1, 5 by 5, 1. Like that, the elements of R2 and R3 are divided by 5. Here also, minus 1, 0, 1. The elements of R2 divided by 5, minus 1 by 5, 1 by 5, 0 5 by 5 is 0. This is 3 by 5. R3 by 5 is 3 by 5. 0 by 5 is 0, minus 2 by 5. Like that. Next, you add this 1, 1, 0. You want this is 0. For that R1 plus R3. Next idea. Next idea is we convert the R1 elements by adding with R3 elements. See, R1 plus R3. Write it in R1. R1 is R1 plus R3 because we should make it this one and this element to 0. For that, because 1, 0, 0 we want, so you will make it to 0, these two elements. For that, R1 plus R3 and you add R1 plus R3 and write it in R1. 1 plus 0, 1. 1 minus 1 plus 1, 0. And minus 1 plus 1, 0. So next 0, 1, 0 is right. And 0 minus 1, 1 you write it. Okay. Similarly, R1 plus R3 on the right hand side. R1 plus R3 minus 1 plus 3 by 5. Minus 1 plus 3 by 5. Minus 1 plus 3 by 5. R1 plus R3. That is 5 1 or minus 5 plus 3. Minus 2 by 5. Minus 5 plus 3 minus 2 by 5. Similarly, 0 plus 0. R1 plus R3. 0 plus 0 0. R1 plus R3. 1 minus 2 by 5. 1 minus 2 by 5. 1 minus 2 by 5. 5. 5 1 is 5. 5 minus 2. 3 by 5. 5 minus 2. 3 by 5. The remaining as it is 1 minus 1 by 5. 1 by 5. 0. 3 by 5. 0. Minus 2 by 5. Next, you convert this element to 0. For that, you add R2 and R3. Final step. You are converting the left-hand side matrix into identity matrix. For that, we have converted 1, 0, 0, 0, 1, 0, 0, 0, 1. We want we convert this second row, second column element by 0. This element we are making to 0. For that, you add R3 is R3 plus R2. 1, 1, 0, 0 as it is, you write. Second row is also 0, 1, 0 as usual. And R3 plus R2, 0 plus 0, 0. Minus 1 plus 1, 0. 0 plus 1, 1. Over. Similar operation on the right hand side. Minus 2 by 5, 0, 3 by 5. Minus 1 by 5, 1 by 5, 0. Next, R3 plus R2. R3 plus R2, 3 by 5 minus 1 by 5. 3 by 5 minus 1 by 5 is 2 by 5. R3 plus R2, 0 plus 1 by 0 plus 1 by 5. R3 plus R2, 1 by 5. And R2 plus R3 minus 2 by 5 plus 0 minus 2 by 5. Over. Therefore, I think we will get the A inverse minus 2 by 5, 0, 3 by 5, minus 1 by 5, 1 by 5, 0, 2 by 5, 1 by 5, minus 2 by 5, good, into A. So this is our A inverse. I equal to A inverse into A. We have this. So therefore this is the A inverse of the given matrix A. Therefore, answer is the right hand side matrix. Therefore A inverse equal to, the answer. Therefore, required A inverse is equal to minus 2 by 5, 0, 3 by 5, minus 1 by 5, 1 by 5, 0, 2 by 5, 1 by 5, minus 2 by 5. This is your answer. A inverse. That's all the problem. So, this is the finding of the inverse of a 3 by 3 matrix by using elementary operations. Okay, we will continue in the next video. We will solve another problem in the next video. I will stop here. You study the problem and you will understand, and we will continue in the next video. Thank you.